Well, good evening, all of you.
Good evening, sir.
Good evening, all of you. Sorry, someone send the message, please. Yeah. So yesterday we have discussed the Maclaurin series, all the theorems, mean value theorems, based on which we are going to write some of the important trigonometric, hyperbolic, and exponential, logarithmic, as well as binomial expansions. Even the binomial expansions are also able to write based on this Maclaurin series. So I repeat that Maclaurin series of the theorem. Theorem means it contains only the finite terms with Lagrange's form of remainder. But Maclaurin series, it is an infinite series saying that f of x equals to f of 0 plus x by 1 factorial f dash of 0 plus x square by 2 factorial f dash of 0 plus x cubed by 3 factorial x cubed by 3 factorial f triple dash of 0. Okay. Now based on this, you please write these now. Yesterday I had explained about e power x and sin x and sin hx. So e power x and sin x were given in the previous examinations, and sin hx, sin x, e power x, both were asked. And similar to them, we are going to utilize so many expansions. Today we'll discuss about those expansions, and as well as we do some simple problems. After that, we'll move on to the next topic, theorems on integral calculus. Okay, is it okay? So let you write some more things. Cos x extraction. ఏంటమ్మా 18th ఎగ్జామ్ ఉందని చెప్పావా ఎప్పుడు ఈ 18th అని ఇట్స్ వెరీ ఇంపార్టెంట్ మీకు చెప్పాలా వెళ్ళి రేపటి నుండి పంపొద్దని చెప్పండి మేడం వాళ్ళ మదర్తో మాట్లాడు ఫోన్ తీసుకెళ్ళండి cos x equals to see here f is cos x f dash is minus sin x f double dash is minus cos x f triple dash is derivative of cos is minus sin. So minus of minus sin x. Fourth derivative of f is cos x and so on. If you keep on writing the function value at zero. So f of 0 is nothing but 1 and next minus, so this is plus 0 plus f double dash is minus 1. So x is 2 factorial into minus 1. F triple dash 0 is 0 plus x cube by 3 factorial. Okay, r0 is 1. X power 4, fourth derivative means x power 4 is 4. Next one will be 0. You are going to write alternately x power 6 by 6 factorial minus 1 plus 1. So cos x is nothing but 1 minus x squared by 2 factorial plus x power 4 by 4 factorial minus x power 6 by 6 factorial plus 1. So this is cos x expansion. Now, if you write cos hx, see, in all these terms, the signs alternately you have to do plus minus, even for sin x also. For hyperbolic functions, cos hx is 1 plus x squared by 2 factorial plus x power 4 by 4 factorial plus x power 6 by 6 factorial plus so on. Okay. Next is tan x. Next is tan x. If you are writing f as tan x, f dash is secant square x, f double dash 2 secant x into secant x tan x. So derivative of secant square is 2 secant x. So this is nothing but 2 secant square x tan x. F triple dash will be 2 secant square x into derivative of tan x is secant square 2 secant power 4x plus So if you differentiate this, again, 2 comes into before this 4 into secant x into secant x tan x into tan x. 4 secant square x tan square x and so on. So tan x is nothing but f of 0 is 0. First term is 0. Second is secant square x. Secant 0 is 1. So f by 1 factorial into 1. Next one will be f double dash 0. Next one will be f triple dash of 0. X cube by 3 factorial. 3 into 2. 2 into secant 0 is 1. 4 into secant 0 tan 0. 0. So you are getting only 2 plus 0 plus if you keep on writing this. The next term will be 2 by 50 x power 5 plus so on. If you write the fourth derivative and fifth derivative, then definitely you will be getting this tan x is nothing but x plus x cube by 3 plus 2 by 50 x power 5 plus so on. Please note down, make it quick fast. Have you written? So these are some important expansions. I'm going to give you some more expansions. Some more expansions based on this McLaren series. McLaren series is nothing but the modification of Taylor series. Modification of Taylor series. The next one is tan inverse x. Same. If F is tan inverse x, F dash is 1 by 1 plus x squared. Element of 1 by 1 plus x squared. F double dash is u by y formula. So if you write 1 plus x squared whole power minus 1, so minus 1 into 1 plus x squared whole power minus 2 into 2x. So F triple dash is, if you write this 2 into 2 minus 2 into minus 1. The product formula of differentiation I am doing here, minus 2 into minus 1 will be 2, 2 into 2x, 4x, 1 plus x squared, whole power minus 3, into 2x, another 2x, derivative of 1 plus x squared, plus derivative of 2x is 2 minus 2 into 1 plus x squared whole power minus 2 and so on. Now if you keep on substituting in this, what is f of 0? Tan inverse 0. Tan 0 is 0, tan inverse 0 is 0. Plus x by 1 factorial. F dash of 0 is 1 by 1 plus 0, 1. Plus f double dash of 0 is, this is 0 and this part is 0. Plus x cube by 3 factorial. But again, if you put x equals to 0 here, this part is 0, 0. This is totally 0. Minus 2 into, this is 1. So what you are getting is minus 2. Plus 1. So this is nothing but tan inverse x expansion. X minus x cube by 3 plus x power 5 by 5 minus x power 7 by 7 plus 1. Keep on writing this. Keep on writing this. Keep on writing this. So sin inverse x expansion, same similar manner. If you write sin inverse x expansion, sin inverse 0 will be 0, first term will be 0. So sin inverse x derivative is 1 by root of 1 minus x squared. It will be getting x plus 1 by 2 into x cube by 3 plus 1 by 2 into 3 by 4 into x power 5 by 5 plus 1. All are positives. Plus 1. Have written all of this. Have written all of this. Yes or no? You say yes, I will Remove these expansions and we will write some more expansions. I will tell. Please send the message. Say yes or no. Have you written or not? All these expansions are very, very important. We are going to write the logarithmic and binomial expansions also. Yes. So log of 1 plus x to the base e. Log of 1 plus x to the base e. If f is log of 1 plus x to the base e, f dash is 1 by 1 plus x. F double derivative is if you have this in the numerator, 1 plus x whole power 1 plus x whole power minus 1. So minus 1 into 1 plus x whole power minus 2. Derivative of 1 is 1, 0, derivative of x is 1. F triple dash is writing this here. 2 into 1 plus x whole power minus 3. Again, derivative is 1. Fourth derivative of f is writing this. Minus 6 into 1 plus x whole power minus 4. Derivative is 1 and so on. So here, you keep on substituting these values. F of 0, put x equals to 0, log 1. What is the value of log 1? Log 1 will be 0. The next term, x by 1 factorial mention 0. X by 1 factorial condition 0 x 1. The next one is x equals to 0. This is minus. So plus x squared by 2 factorial into minus 1 plus x cubed by 3 factorial triple derivative. Put x equals to 0, 2. And fourth derivative plus x power 4 by 4 factorial into put x equals 0 minus 6 and so on. So the expansion is nothing but x minus x square by 2 plus x cubed by 3. Here 6, 3 into 2 will get cancelled. You are getting only 4 minus x power 4 by 4 plus so on. Please note down this. Here for log of 1 plus x, alternately you will get plus minus and so on. Okay. Now log of 1 minus x to the base e. Log of 1 minus x to the base e. If you replace x by minus x, you are getting 1 minus x. Put x as minus x. This is minus x. And here minus x whole square. So that you are getting minus as this. Minus of minus x whole square. That will be minus x square by 2. Here minus x whole cube. Minus x cube by 3. Again this minus x whole power 4. Minus x power 4 by 4 plus 1. All are negatives. Log of 1 minus x to the base e is nothing but all are negatives. Make it fast. In the same manner, you may write an expansion of 1 plus x whole power minus x. Consider this as f of x. F of 0 is 1. And f dash of 0 minus n into 1 plus x whole power minus n minus 1. So therefore minus nx by 1 factor. And second derivative will be minus n into minus n minus 1. That is plus n into n plus 1 into 1 only. So you will be getting by x square by 2 factor. So x square by 2. The next one will be plus or minus third derivative minus n minus 1 into minus n minus 2. So you will be getting obviously minus n into n plus 1 into n plus 2 by 3 factorial into x cube plus so on. This also you can write based on the Maclaurin series. Considering f of x as 1 plus x whole power minus n and finding their derivatives respectively, first derivative, second derivative, and putting x equals to 0 everywhere, all those infinite series terms. So you keep targeting 1 plus x whole power minus n expansion. In the same manner, you may write 1 minus x whole power minus n. So if you keep on writing 1 minus x whole power minus n expansion, x is going to be replaced by minus 6. So this will be plus. So 1 plus nx. And x will be replaced by minus x whole square. So what you are getting is plus n into n plus 1 by 2 factorial into x square. Again, x is replaced by minus x. So minus will come, minus of x will be plus. Plus n into n plus 1 into n plus 2 by 3 factorial x cube plus so on. Plus so on. So keep on writing this. Try to finish it. If you are finished, please send me the message. Are you finished? You have finished, please send a message so that we can do the problems on it. Please send a message. Have you finished? Say yes or no. I know next. I have a problem which you can explain. Find the expansion. Find the expansion of sine plus 3x minus 4x. Sine inverse of 3x minus 4x cubed. Everybody got it or not? So here, from the questions or the options, the series will be given like this. You will be given the series like some constant plus x by 1 factorial or x squared by 2 factorial x cubed by 2, something else like that. Or you may have some more terms or you may not have some other terms. Okay. So it is clear or not? Now, actually, sine inverse expansion is sine inverse expansion is, sine inverse expansion. Sine inverse x equals to sine inverse x equals to, already we have written something else x plus 1 by 2 into x cubed by 3 plus 1 by 2 into 3 by 4 into x power 5 by 5 so on. Don't substitute this in that. You cannot write the expansions of all of those. So here I'm going to take in place of x, I'm going to take this of x equals to sine theta. Then theta equals to sine inverse x. You substitute that here. This will be sine inverse 3 sine theta minus 4 sine theta. So this is equals to sine inverse of sine 3 theta. Okay. Sine inverse of sine means it is nothing but 3 theta. This is equals to 3 sine inverse x. You can write the expression sine inverse. This is equal to 3 into what is sine inverse x expansion? X plus 1 by 2 into x cubed by 3 1 by 2 into 3 by 4 into x power 5 by 5 is on. Do it quick, make it fast. Is it okay? So the expansions will be in terms of some constant plus, some coefficient into x plus, some other coefficient into x power x squared, if it is existed, some other coefficient into x power 5, or x power 3, some other coefficient into x power 4, some other coefficient into x power 5, and so on. The expansions will be like this. Do remember the expansions will be like this. Right, the next one. Everybody got this or not? Right, the next one. Mine. Sine inverse of x by 1 plus x squared. Find sine inverse of 2x by 1 plus x squared. Please send a message. Everyone is finished or not? Please send a message. All is finished or not? This one is finished. So here also for this expansion, if you do remember the trigonometric formulas, then you can do it very easily. So the other one is sine 3 theta formula. This is related with if you put sine theta by 1 plus sine square theta, you won't get anything. In examination, so if you are having 1 plus x squared or root of 1 plus x squared, try to substitute x equals to tan theta, then it will be reduced into some simple form. If you are having 1 minus x squared, square root of 1 minus x squared, then try to put x equals to sine theta or cos theta. If you are having square root of x squared minus 4, in order to simplify, put x equals to secant theta. Then based on the trigonometric expansion, you can easily simplify those things. So here we are having 1 plus x squared. So therefore I am going to take the substitution x equals to tan theta. So this is sine inverse of 2 tan theta by 1 plus tan square theta. One plus tan square theta. So 1 plus tan square theta is nothing but what is the value? 1 plus tan square theta. Tan square theta minus tan square theta equals to what? 1 plus tan square theta equals to secant square theta. So this is equal to sin inverse of 2 tan theta. 2 into sin theta by cos theta. This is here 1 plus tan square theta is secant square theta. So secant square theta is 1 by cos square theta. So 1 cos theta gets cancelled. So if bring this into the numerator, this is equals to sin inverse of this is equals to sin inverse of 2 sin theta cos theta. Nothing but sin inverse of sin 2 theta is equal to 2 theta is equal to theta. X is tan theta. Theta will be tan inverse x. 2 into tan inverse x. 2 into what is tan inverse x expansion? Already you have written tan inverse x expansion. What is tan inverse x expansion? Tan inverse x expansion is x minus x square by 2 plus x cube by 3 minus x power 4 by 2 plus 2. Please note down. Did you finish? Try the next question. Tan inverse of root of 1 plus x squared minus 1 by x. Do it quick. Have you finished the above one? You finished the above one or not? Say yes or no, no response. Please send the message. Some of you please send the message. Please send the message. Right here, like in the previous problem, 2x by 1 plus x squared, as we have taken x equals to tan theta. So for 1 plus x square or root of 1 plus x square, put x equals to tan theta. Okay. So therefore, in the same manner, here also root of 1 plus x square we are having. Same thing, put x equals to tan theta. Put x equals to tan theta. So 1 plus tan square theta. This is equals to tan inverse of root of 1 plus tan square theta will be secant square theta. That is nothing but secant theta minus 1 by tan theta. By using this substitution, you are getting root of 1 plus x square is nothing but secant theta. Secant theta minus 1 by tan theta. So this is equals to tan inverse of this is 1 by cos theta minus 1 by sin theta by cos theta. So if you take MCM 1 minus cos theta by sin theta, this is equal to tan inverse of 1 minus cos theta by sin theta. This is equal to tan inverse of here 1 minus cos theta is nothing but 1 minus cos theta is nothing but 2 sin square theta by 2. And sin theta in terms of half angles, you can write it as 2 sin theta by 2 cos theta by 2. So 2 gets cancelled, sin gets cancelled. Sin theta by 2 by cos theta by 2. Tan inverse of tan theta by 2. Tan inverse of tan theta by 2. So this is nothing but half theta or half tan inverse x. 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 Right expansion of tan inverse x. 2 by 2 into x minus x square by 2 plus x cube by 2 minus x square by 4 and so on. This is nothing but 1 by 2 into x minus x square by 2 plus x cube by 3 minus x power 4 by 4 and so on. Please note down, make it quick fast. After finishing it, please try to send me the message. Send me the message. Whether you are finished it or not. Say yes or no. Respond. Please respond. Send me the message quick, fast. Yes. Find the next one, and by using the Taylor series also, this is also another application of Taylor series. Maclaurin series is nothing but the modified form of Taylor series. By using Taylor series directly, we can find the functional values like logarithmic or trigonometric, whatever the functional values, which are very nearer to the known values. Suppose if you know the value of sine 0, sine 0 is given as 0. You can find sine 1 degree. You can find cos 1 degree. Because cos 0 is 1, you can find cos 1 degree. Sine 90 is 1. So you may find sine 89 degrees or sine 91 degrees. You know log 1 is 0 and you can find log 1.1. That kind of things you may obtain based on the Taylor series expansion. Let us observe one problem. Afterwards, we will move on to the next topic, theorems on integral calculus. Okay, right now. Find the value of log 1.1 to the base e. Log 1.1 to the base e. See here, log 1.1 to the base e. You know log 1 value. Log 1 is nothing but 0. Log 1.1. So find it. So use the calculator, but in the examination it may be asked. Express log in terms of x minus. We have to express log x in terms of x minus 1. How to express log x in terms of x minus 1? So consider f of x as log x. Okay. You know, by Taylor series, f of x equals to f of a plus x minus a by 1.2 dash of a plus x minus a whole square double dash of a plus x minus a whole square 3 factorial plus triple dash of a plus 1 plus 1. I am using this Taylor series expansion. This is nothing but Taylor series expansion. Expressing f of x in terms of x minus a. Here f is log x, f dash is 1 by x, f double derivative is minus 1 by x square, f triple derivative is minus 2. So therefore 2 by x cube and so on. Here, what I am writing is in place of f, write log x. So log x and taking a equals to 1. F equals to log x and taking a equals to 1. So this f of x is nothing but log x is equal to f of 1 plus x minus 1 by 1 factorial. F dash of 1 is to x equals to 1. 1 x minus 1 whole square into factorial. F double dash of a is double dash of 1 minus 1 plus x minus 1 whole cube by 3 factorial. F double dash of 1 is 2 by 1 cube, 2, and so on, and so on. So it is very clear, log 1 is 0, f of 1 is 0. So you can write this as x minus 1 minus x minus 1 squared by 2 plus this is 2 get cancelled, x minus 1 whole cube by 3. Alternately, minus plus will come, minus 1. This is the thing. Expressing log x in terms of x minus 1. So, the question you may be given log x equals to. Among the options, you may be given this kind of expansions. You can write. You can write this kind of expansions. And as I have asked log 1.1, put x equals to 1. Now log 1.1 would basically equals put x equals to 1.1. 0.1 minus 1. 0.1 minus 0.1 square by 2 plus 0.1 whole cube by 3 minus 1. This is equal to 0.1 minus 0.1 whole square is 0.01 by 2. Nothing but 0.005. 0.01 by 2, 0.005 plus 0.1 whole cube is 0.001. So by 3 means 0.0003 minus 1. So if you do simplify this, calculator complete this program, use this formula only to get such kind of values. So 0.1 minus 0.005. What is the value? 0.095. Add this, that will be 3. This is the answer. This is the answer. So in examination, you may expect log x expansion in terms of x minus 1 or something else, sin x expansion in terms of x minus pi by 2 or cos x expansion in terms of x minus pi by 2, like that. So this is one basic application of Taylor series. So these are the questions you can expect in examination from mean value theorems. Some of the questions which were asked there, I've already given it to you, and some types which you can explain, already explained. Now let us move on to the next topic. Theorems on integral calculus. Theorems on integral calculus. Please write. Theorems on integral calculus. Theorems on integral calculus. So integral calculus means calculus. For calculation purpose, we are going to use some integration formulas. So we will discuss some important formulas, and we'll be knowing about how those fundamental integration formulas were derived. Okay, how to remember them. These are the things that we need to discuss now. Have you noted this? Is it finished or not? Please send the message. Please send the message. Say yes or no. Write down fundamental theorem on integral calculus. First one. Fundamental fundamental theorem on integral calculus. Fundamental theorem on integral calculus. So in order to do the integration, this is very, very important. These conditions are required. Please note down if x is continuous and closely x is continuous and closely continuous and closely and where x is a differentiable function. Differentiable function. Capital F of x such that f dash of x equals to small f of x. F dash of x equals to small f of x. F dash of x equals to small f of x. That is, f is the primitive of small f. Primitive of small f. F is the primitive of small f. Primitive of small f. Primitive means what? If you do integrate here, that you will get cap left. This is the solution of that. Primitive means solution. That means if you differentiate, you will get that. Integrate that, you will get this. So that is the meaning of it. Then integral a to b, then you can say small f of x is integrable on cos a. Also integral a to b small f of x dx equals to capital F of a minus capital F of a. Integral a to b small f of x dx equals to capital F of b minus capital F of a. Have you written? One very simple thing is, see, this is connected here. This is connected. Differentiation means I am separating this at this point. Integration means you add all those small parts. That is nothing integration. Differentiation means separation. Integration means adding all those small parts into a part of it. So differentiation and integration both are anti-processes of each other. Now I have written capital F dash is equals to small f of x. So in place of small f of x, if you write capital F dash of x, integral a to b capital F dash of x dx equals to integration and that derivative gets cancelled. So you are getting only capital F of x. So capital F of x, on writing the upper limit b, you are getting capital F of b. Upper limit minus lower limit. Capital F of b minus capital F of a. Capital F of b minus capital F of. You are having f of x. You are having capital F of x. After cancelling the integration and differentiation. So in capital F of x, you have substitute the upper limit, that is capital F of minus small f of minus capital F of. That is integration. That's it. This is fundamental theorem of integral calculus. So have we written this? Now let us do a problem related to this. What was given in the previous examinations. So in order to do the integration, it must be continuous. there must be a differentiable function. There must be a differentiable function such that if greater than equals to small f of x, now this small f of x can be easily integrated. Okay. Say yes or no? Say yes or no? So if you send the message, I'll start the problem. Write on a problem based on this fundamental theorem on integral calculus, which was given in the previous examinations. Please slow down, quick, make it fast. If f of t is continuous for close 0, 1, f of t is continuous over close 0, 1, then limit t tends to 0. Limit t tends to 0. Limit t tends to 0. One by t integral 0 to t f of x dx. F of x dx is equal to I'm giving you the options. Option A, f dash of 0. Option B, f dash of 1. Option C, f of 0. Option D, f of 1. This was asked in the previous GATE examination. Right. See here, we have given the function is continuous for this interval, and we have given integral 0 to t f of x dx. That means the function is integrable, and there will be some differentiable function capital F such that there will be some differentiable function capital of x such that capital F dash of x equals to small f of x. Okay, it is already existed. If you know that definition, then only you can assume this. Because in the problem it is given 0 to t f of x dx is existed. It is given means it is existed. So what is this now? As f of x is given, there must be a differentiable function capital F of x. Differentiable function there exists. Differentiable function capital F of x such that dash of x is small f. Now integral 0 to t small f of x dx will be equal to, as per that fundamental theorem on integral calculus, this is capital F dash of x dx. This is equal. Derivative and integration cancel. Capital F of t minus capital F of 0. Capital F of t minus capital F of 0. So therefore, so you have got this. So just substitute in this. Limit t tends to 0. 1 by t integral 0 t f of x dx. This is nothing but limit t tends to 0. This value is nothing but capital F of t minus capital F of 0 by t minus 0. Limit t tends to 0, capital F of t minus capital F of 0 by t minus 0. Okay. While we have discussed the formulas of differentiation, you might have noted that this is nothing but capital F dash of 0. This is the definition of derivative of capital F. But what is capital F dash? Is nothing but small f. So this value is nothing but small f of 0. Okay. So small f of 0 is the answer. Please note down. Make it quick fast. Make it quick fast. Have you finished? Please send me the message. Please send the message. Send the message. Try the next one. Next one, next theorem, that is also very important. Integration by parts. Integration by parts. Second one. Integration by parts. Right. If capital G of x are two differentiable functions. Are two differentiable functions over closed area such that capital H of x is equals to small f of x, comma capital G H of x is equals to small g of x, and are integrable and are integrable on closed area. And our integral line close to AB, then integral A to B capital F of x into G of x dx is equal to capital F of B G of B minus capital F of A G of A minus integral A to B small f of x capital G of x dx capital G of x dx. See here, you may be knowing integration by parts formula. That is nothing but integral b plus 2 into integral b minus integral derivation of 2 into integral b. Okay, this you know better. This you know better. But how this will come? How this will come? Consider if it is from A to B. This about the limits from A to B. Here also from A to B. Now, if you consider capital F as U, small g as V. Okay. Now, as per this, U into integral B. U means capital F. Capital F. Integral small v means integral small g. What is integral small g? If it is integral small g will be capital G. So that is equal to capital G. Limits from A to B. Okay. If you write the upper limit, capital F of B, capital G of B, minus lower limit, minus lower limit capital F of A, capital G of A, minus integral A to B. Derivative of U means derivative of capital U. So U means capital F. Derivative of capital F is small f. Integral of small v means integral of small g means integral of small g means capital G. That's enough. You have got the same formula. So normally you people may be using this in order to evaluate integration by parts. But here, what we are getting is this one came from this formula only. This is integration by parts. So for this, the conditions are capital F, capital G must be differentiable. Their derivatives are integrable, and based on this formula, we have got this. So this is integration by parts formula. Now, while applying this integration by parts formula, you may have a doubt. What is that? Which one to be considered as U? Which one to be considered as V? So in this UV formula, you have to follow ILAT. ILAT. ILAT means I for inverse. L for logarithm. A for algebraic. Algebraic. T for trigonometric. E for exponential. E for exponential. So based on this order, whichever comes first, that is to be considered as U. Among the given functions, if inverse function is given in the product, like x is sine inverse x, sine inverse is inverse, x is algebraic. So among x and sine inverse, inverse to be considered as U. The next one as B. So if you are having logarithmic x log x, logarithm to be considered as U in this formula, and x is log algebraic. So that x has to be considered as V. Suppose if e power x comes, that has to be taken as V. X e power x. X is algebraic, is before to exponential. So x to be taken as U and e power x to be taken as V. So this kind of order you have to maintain. While applying this integration by parts, this highlight formula need to be followed in order to choose which one is U and which one is V. The previous examination, if people have got a question, please note that. Integral 1 to E. Find the value of integral 1 to a root x ln of x dx. Find the value of integral 1 to a root x ln of x dx. I have given you the options also. Please put the options. 4 by 9 root e cube plus 2 by 9. Option B. 2 by 9 root e cube minus 4 by 9. Option C. 2 by 9 root e cube plus 4 by 9. Option D. 4 by 9 root e cube minus 2 by 9. Please do it, make it quick. It is based on integration by parts. To make it fast. So here, as per this highlight formula, root x is algebraic. ln x is logarithm. ln means natural logarithm. Natural logarithm. So this is, as per this order, the logarithm is before to algebraic. So consider this ln x as u and this root x as v. So this value is equal u into ln x into u into integral v. Integral of root x. Root x. So we will find the limits 1 to a minus here integral root x means integral root x dx minus integral derivative of u integral 1 to a derivative of root x, that means d by dx. We are doing integration with respect to x means derivative may be also taken as derivative with respect to x into integral v. Integral x dx all dx. So this formula I have written here, and I have chosen u as ln x because it comes before the algebraic, and root x is algebraic. So therefore this is equal. Integral of root x is x power 3 by 2 by 3 by 2 into ln x. Limits from 1 to a minus integral 1 to a derivative of root x is derivative of ln x. Root x ln x. Derivative of ln x is 1 by x. Integral of root x is x power 3 by 2 by 3 by 2 dx. It is finished. Here comes the answer. This 2 by 3 on writing upper limit. Natural logarithm of e, ln of e minus ln of e into e power 3 by 2. This is e power 3 by 2 minus ln of 1 is 0. 0 and anything is 0. Minus 2 by 3 into 1 by x, x power 3 by 2. So 1x gets cancelled. X power 1 by 2 remains. So for that, x power 1 by 2, do the integration. Again, it will be x power 3 by 2 by 3 by 2. Again, limits from 1 to e. ln of e is natural logarithm of e. But there is no base. Base needs to be considered as e. So what is that now? What is that now? ln of e to the base e is 1. E power 3 by 2. 2 by 3. E power 3 by 2. Minus 4 by 9. E power 3 by 2. Minus 1. If you do simplify, 2 by 3 e power 3 by 2 minus 4 by 9 e power 3 by 2. Take LCM 9. 2 into 3, 6. 6 minus 4, 2. So therefore, 2 by 9 e power 3 by 2 minus of minus plus 4 by 9. That is the answer. 2 by 9 e power 3 by 2 minus of minus plus 4 by 9. This was also asked in the previous one of the GATE examination. Please note down. If you have finished, please let me know. We'll go on to the next formulas or the next theorems. We have to do it. We need to finish all these things itself. Have you finished? Say yes or no. Please respond. Please respond. Write down the next important theorems on integral calculus. Integral a to b f of x dx is equal to minus integral b to a f of x dx. See here, if you flip the limits, the value will be negative. On interchanging the limits, the value will be negative. Next, integral a to b of x dx is equal to integral a to b f of t dt. See here, the variable x-axis is replaced by dt. If the variable x-axis is replaced by dt or uu or vv, whatever it may be, the nature of the function was not changed, and also the limits were not changed. So the value of the integral remains the same. Value of the integral remains the same. Next, integral a to b of x dx is equal to integral a to c f of x dx plus integral c to b f of x dx, where a less than c less than b. If c is a value lying in between a and b, that integral a to b f of x dx can be split into two integrals. Integral a to c f of x dx plus integral c to b f of x. Can split that into two integrals, provided that point c lies in between a and b. Next. Next. Integral 0 to a f of x dx equals to integral 0 to a of a times 6x. Provided a is positive. Like here, 0 to pi by 2 sin x dx equal to 0 to pi by 2 sin pi by 2 minus x dx. Sin pi by 2 minus x will be cos x. So integral 0 to pi by 2 sin x dx will be equal to integral 0 to pi by 2 cos x dx. By writing that value, both will be same. Doing integration, you will get the same value. And this you will write as polar limits. Of x dx equals to to be for a plus b minus x dx. A plus b minus x dx. Okay, here this 0 to a we are having a to b. 0 plus k minus x. A plus b minus x. That's enough. And this one is very, very important integral minus a to a of x dx equals to 2 into integral 0 to a f of x dx. If f of x is of minus x equals to f of x. F of minus x equals to f of x. That is, f of x is even function. F of x is even function. And this is 0 if f of minus x is minus f of x. That is, f of x is odd function. Odd function. Odd function means f of minus x equals to minus f of x. Even function means f of minus x equals to f of x. Please note on this. So let me give you a problem related to this. This formula was directly asked once. This was directly asked once in the examination and several times it was a problem. Some problems related to these were asked in the previous examinations several times. Okay. So this is very, very important formula. This is based on even and odd function. Right, next. Two more similar formulas. Integral 0 to 2a integral 0 to 2a f of x dx. Zero to 2a f of x dx is equal to 2 into integral 0 to a f of x dx if f of 2a minus x equal to f of x. And this is 0 if f of 2a minus x equals to minus f of x. Okay. Please note. Integral 0 to 2a f of x dx equals to 2 into integral 0 to a f of x dx if f of 2a minus x equals to f of x. And it is 0 if f of 2a minus x equals to minus f of x. Minus f of x. Next one. Integral 0 to n f of x is equal to n into integral 0 to a f of x dx if f of a plus x equals to f of x. And n is positive integer. N is positive integer. Is it clear? Is it clear? Say yes or no, is it clear? If you send the message, I'll give you some problems you could given based on this in the previous examination. Please tell me quick, make it fast. Send the message. Send the message. Please send the message. Please send the message. No, I don't think so. You are not sending any message. So let me do a problem which was given in the previous examination. Integral minus a to a sine power 6x plus cos power 7x. Dx. Sine power 6x write down the options. Sine power 6x plus sine power 7x. Not cos, it is sine again. Sine power 7x dx. Where a is greater than 0. Write the options. Option A 0, 3. 2 into integral 0 to a sine power 6x plus sine power 7x dx. Option C 2 into integral 0 to a Sine power 6x dx. Option D. 2 into integral c to sine power 7x dx. Sine power 7x dx. Please write down this. Note and do it based on that eighth formula. Right. Please note down this and apply the formula. Tell me the answer. Which one is the answer? Now make it fast. Yes, sir. Make it fast. For you people only these sort of questions can ask. Very simple questions. Make it quick. A is positive. Now among the sine power 6x and sine power 7x, which one is even and which one is odd? You know that. Sine of minus x equals to minus sine x. And sine power 6 of minus x equals to minus 1/6 times. This is equal to sine power 6x. Sine power 6x is even function. Next, sine power 7 of minus 6x minus 1/7 sine power 7x. It's equal to minus sine power 7x is odd function. So here this is even and this is odd. So you can say the answer. For odd function, if it is odd, that value will be 0. If it is even, that value will be 2 into 0 to a f of x dx. So this value you can find x. And minus a to a sine power 6x plus sine power 7x dx is equal to 2 into integral 0 to a. You can split that into two parts, plus or minus. Sine power 6x because it is even. And this is odd. So for that part, the value will be 0. This is answer. The answer is C. Option C. Answer is option C. And the next one. Integral 0 to pi by 2. Integral 0 to pi by 2. Cos x plus I sin x by cos x minus I sin x dx. I sin x dx. You may write the options. So options not at all required. You can write the answer quickly. Tell me the answer quick. You have to remember this one for this. E power I theta equals to cos theta plus I sin theta. Okay. And if this will be e power minus I theta. Cos theta minus I sin theta. So you may use that and tell me the answer quick. You can do the integration very easily. Simple questions were asked previous. What is the answer? This is equal to integral 0 to pi by 2 is e power ix by e power minus ix. Here I is nothing but square root of minus 1. I to know in one is equal to number. This is equal to writing this into the numerator 0 to pi by 2 e power I to x dx. Integration of it e power I to x by I into 2. Limits from 0 to pi by 2. Basic integration formula. Integral e power ax is e power ax by a. Basic integration formula. Integral e power ax is e power ax by a. If you write pi by 2 here, e power I pi. On writing lower limit, e power 0 by 2i. By 2i. E power I pi is cos pi plus I sin pi. Cos pi is minus 1, sin pi is 0. So this is minus 1. E power 0 is also minus 1. By 2i. So 2 gets cancelled. So minus 1 by I. Nothing but I said I square I equal to root of minus 1. I square equal to minus 1. If you write that minus 1 as I square, I is cancelled, I will get the answer. And here cos pi is minus 1. You might have remembered, if it is not so, I will write here. Sin pi is 0. So now down, make it quick fast. You finished? This is asked for computer science only. Because you might be forgetting about the imaginary numbers and that complex numbers. So that's why it was given for you. And write one more. Find the value of yes, maths. Where I'm going to put oh, and but do this integral 1 to infinity x power minus 3 dx. Just ordinary integration. X power minus 3 plus 5 minus 3 plus 1. Limits from 1 to infinity. So this is equal to x power minus 2. Writing that in the denominator. 1 by minus 2. This is minus 2 x squared. Limits from 1 to infinity. So if you write infinity in place of x, that will be 0. I'm writing the upper limit is 0 minus 1 in place of x minus 1 by 2. So the answer is 1 by 2. If it is asked numerically answer the question, write 0.5. Okay. Have you written? Have you written? Please respond with the message. Yes. Here there are some simple questions based on the theorems on integral calculus you people are getting. And two to three different types are there. Tomorrow we will discuss. Afterwards, we will start maximum minimum. Based on maximum minimum, you people are getting the questions many of the times. So mostly we'll discuss the maximum minimum. We'll try to finish by tomorrow. That maximum minimum. So that closes ordinary calculus. Afterwards, we will start the discrete mathematics. In discrete mathematics, we are having propositional calculus, which is very important. You may get 3 to 4 marks. And graph theory, you may get 3 marks from graph theory. And then few topics of set theory and algebra and combinatorics. So that will finish as the discrete maths also. So tomorrow, doing 1 or 2 problems on this different types which were asked in the previous examinations, we will discuss maximum and minimum. Okay, then you can take leave. But today, tomorrow, we will continue the class.
Thank you,
Is
sir.
it okay? Send the message. Is it okay or not? Yes. You may take leave. Tomorrow, we will continue this.